That's the only possible, and even then probably a little bit outlandish, only possible question I can conceivably think of that you might get on the CCNA exam regarding IPv6. You go into CCNP and they'll ask you a lot more in-depth stuff on classes of IPv6 and what they do and that kind of thing. But this is probably the most complicated question you're going to get on IPv6, I would imagine, on the CCNA.
So are there actually subnets for IPv6, or is it just kind of like included as the IP address?
Wait, what do you mean? Like
you're going to have like the 192.168.255.255.252 for like a regular IPv4.
Mm-hmm.
So is there like another like separate subnet for the IPv6 that there is IPv4?
You kind of have to like think of it as completely separate than IPv4. Now you're going to have like a CIDR notation for it, but it doesn't really. It is counting on powers of 2, but like to break it down into just like 255 to 252 kind of thing doesn't work because you've got more bits than 8 in it. So and the CIDR notation, since it's broken up into the 64-bit network prefix and the network identifier, the CIDR notation is only corresponding to the last half. So like, you got a line right here. All of these are going to stay the same, throughout that network, and only on this last part are you going to have like it counting up or down on the network bits. So you would start with, for like this one, the first IP address in that would be, all these all zeros, and then all of these all zeros as well, and that would be a slash. I guess a slash is 0. Yeah.
Why is it referred to in hex instead of decimal?
Well, you'd have to have
6 octets.
Yeah, you'd have to have. Well, let's see. So it's 6 sets. The numbers would definitely have to go beyond 255. Like even if you were breaking them down here, because it would be 4, 8, 16, 32. So 2 to the 32 is what?
What?
Is that what we just looked up?
No.
Wasn't that the 16 million or something?
No, 2 to the 24.
That was 2 to the 24. What's 2 to the 32?
4 billion.
That's why they don't do that. Okay. That's why they have it as hex, because you would have like, your first, it wouldn't even be, well, it wouldn't be an octet. It would be a
sextet or something.
What's to the 32? 8 is an octet. What's a 32? I don't even know. Well, in each of those, they would even be longer than. It wouldn't be longer, but it would almost be easier just to write it as straight binary, because like the numbers would become so astronomically large.
Yeah.
I mean, because otherwise what would end up happening is you would have to break these into, break these things in half, and then you would be left with, how many, 12, 24, a lot of numbers.
Yeah.
Here, I mean, you've already, like, even with these as hexadecimal, you still have a lot of digits in there. Like, just looking at that, that's a lot to remember. Once we get into IPv6, I guess you can pretty much wave goodbye to being able to, like, copy an IP address.
Yeah.
It's going to be some copy-pasting going on to not, like, screw up one digit and really mess something up.
So I understand sort of the CIDR notation that's there. And, of course, for all networks, we'll need a gateway, a subnet mask, and an IP address.
Mm-hmm.
Have they given any examples of what this looks like when you actually configure your device?
Well, okay, so, like, this one, well, it's not going to have a, I'm trying to think. I haven't actually pulled it up in Windows to see like how it looks, but it's not gonna. The configuration like in a Windows PC would be different. You wouldn't be configuring like a 255 anything. So you would just be putting like, because in a like in a FortiGate, if you're manually configuring an interface from the GUI, you can just put in the IP address and then slash the CIDR notation or slash and the subnet mask. Mm-hmm. So this is going to be limited to just doing the CIDR notation. Like there's not going to be an option for that. And then your gateway, if you were manually assigning a gateway, presumably like on this, it would be a 2001 0BD blah 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 0001. But I may be incorrect on that. I'm trying to remember the deeper stuff on IPv6, and it's pretty weird because you don't have just like a single IP. Like a lot of devices will. This is going way beyond like what you're going to be testing on the CCNA, but a lot of times devices will have like numerous IPs assigned to them. I can't remember the exact number. I know it's like 4 or something, because you'll have like a link local, a link global address, a link local address, a link global address, in fact,
Multicast,
I didn't
unique site local.
Oh yeah, okay. Actually,
It's in the book.
okay, it is actually in this book. I put a slide on it. Forgot about it. So you got 4. Yeah, you have exactly 4 types of IPv6 address. So your link local address is going to be limited to your layer 2 domain. So with IPv6 addresses, you're not even like just limited to layer 3. Like you're going to have an IP address, an IPv6 address that corresponds to your layer 2, and it's always going to start with that FE80. The last 64 bits include the MAC address, so it'll be the FE80 something for another 48 bits, and then the last 64 bits, the last half of that IP address are just going to be your MAC address with FFFE squeezed directly into the middle of the MAC, if that didn't make it any more confusing for you. So that's your link local address just for layer 2. You've got your unique site local address, which is limited to an organization's network. So that would be like the equivalent of, instead of having NAT, but I guess kind of like having NAT, you have your 10 dot address, and that would correspond to a public address. Yeah, exactly. And then you'd have a global address, which would be publicly routable. It's named global. And then the multicast address for broadcast group and broadcast communications, and that's always going to start with the FF. So it's a whole different ballgame on IPv6. Like it's a lot of the concepts are the same. Subnetting still works very similarly, like on a binary level, but you got multiple IP addresses assigned to every device to correspond to different network functions. So yeah.
So the unique site local address and I guess the global, is that sort of like when you have the in the Cisco you configure the IP route statement so that it recognizes that you've got traffic that does not belong to any of the networks within it. It decides to send it out to the IP route statement and out.
Kind of. I think I get what you're saying. Yeah, like for the unique site local address, like you're only for those sets of IPs, you're only going to be able to communicate with who's on your like local subnet in your corporate network or whatever it happens to be. But if you're responding on your global address, it's going to be able to route beyond that to the public internet, so you can access web pages and all that kind of stuff.
Yeah, I started reading that and I was like, I don't want to learn about this right now.
I forgot this was even in here. I thought so there. I guess there is a chance like you might get to answer your question a little bit better. Like other possible questions you could get on IPv6 would be. I know I had some on the CCNP exam. I really don't think I had some on the CCNA exam. Would be like one where you have a link local address, FE80, and then you have to be able to identify like what the MAC address was from that device and be able to decipher, okay, well it's these last digits minus these crap digits just jammed in the middle for no real reason or no foreseeable reason. And like on the CCNP exams, like they get into a lot more about like what unique site local addresses and global addresses, the types of blocks those will usually start with, so you would be able to identify like based on some IP addresses where they'd be going. And then multicast addresses, they go way more in depth on that, on like FF, and then they have a couple characters that follow that correspond to this type of multicast, and FF, and then a couple different characters would correspond to this other type of like multicast addressing. So I don't think you're really going to get anything like that, but being able to memorize just what the difference is between a link local, a unique site local, global, and multicast address is probably going to be at least a good idea, even if you get tested on it, I doubt you'll get tested heavily at all. So, okay, and that's all I've got. So, any other questions on my poorly prepared